Hello, can you hear me?
Yeah.
Yeah. Uh, okay, so you sent a couple of doubts, right?
Yeah.
Okay, so let's look at that. Question 18. It says let P 4 comma minus 4 and Q 9 comma 6 be 2 points on the parabola. P 2 points on the parabola y square is equal to 4x. Okay, x be any point. X is any point on the arc POQ of this parabola, where O is vertex. Vertex of this parabola is 0, 0. So O is 0, 0. Such that area of triangle PXQ is maximum. Such that area triangle PXQ is maximum. Then the maximum area is what? Okay, so you have a parabola like this. You have to find the maximum area. Let's say 4 comma minus 4, 9 comma 6. So this is, let's say, 9 comma 6. This is your Q, and 4 comma minus 4 is somewhere here.
Yeah.
4 comma minus 4. O is this point. You have to find x such that area triangle PXQ is maximum. So x can be somewhere, let's say, here. This area is maximum, right?
Yeah.
Okay, so fine. X is an arbitrary point such that this area is maximum. So x can be written as what? X can be written as t square, 80 square comma 280, right? And a is 1, right?
Mm.
So it is t square comma 2t.
Oh, yeah, yeah.
So then there is only one variable t and two other variables are known, right? The
Uh-huh.
two other vertices are known. There is only one variable t. So area of triangle can be written in terms of just t, right?
Oh, yeah, yeah.
And then there is maximum minima. It's obvious. Area of triangle will be written as half of 9, 6, t square 2t, 4 minus 4, 9, 6. And you do shoelace method, you'll get half of mod of 18t minus 4t square plus 24 minus 6t square minus 8t plus 36. It will become minus 10t square, 10t. So 10t minus 10t square plus 60 and half of mod of this. So 10 can be taken outside, it becomes 5 times mod of t minus t square plus 6, right?
Yeah.
Find the maximum value of this. So if it is mod, we can take minus 1 outside. It is t square minus t minus 6 5 times.
Mhm.
Or we could have kept it like this only, minus t square plus t plus 6. That is a parabola like this. So maximum value will be when t is equal to minus p by 2. T is equal to minus 1 by 2 into minus 1. So 1 by 2. At t is equal to 1 by 2, the value is coming out to be minus 1 by 4 plus 1 by 2 plus 6. So this becomes 6 plus 1 by 4. So that becomes 25 by 4. And 25 by 4 into 5 is 125 by 4. That is the maximum area,
Yeah.
right?
Yeah.
So what was your problem? What happened?
No, I just didn't put the parametric form in directly.
Then what did you put x, y?
Yeah, like that and all that.
If you don't use parametric form, it will be annoying because there will be two variables.
Yeah.
Parametric form is useful because of such situations only, no? That it reduces the number of variables.
Yeah.
The next one was if the tangents and normals, if the tangents and normals at the extremities of a focal chord, at the extremities of a focal chord of a parabola, focal chord of a parabola intersect at x1 y1 and x2 y2 respectively, and x2 y2 respectively, then what can you say between these two? What relationship holds? This is fairly straightforward. If you have 2 points at1 square 2at1 and another point at2 square 2at2, where do the tangent at this and tangent at this intersect?
Mm.
Intersection point of tangents has a nice parametric form. Do you remember?
No.
At1 square t1 at1 t2 t1 plus t2, that type of form is there, no, for point of intersection of tangents.
Yeah. A T1, T2, and A T1 plus T2. Yeah.
So at1 t2 at1 plus t2, point of intersection of normals also has a form. Where is the point of intersection of normals?
So
It's a slightly
A,
longer one.
A T1 square plus T2 square plus T1 T2 plus 2.
Point of intersection a
A
t
whole
square
T1
plus t2 square plus t1 t2 plus 2,
yeah,
and then minus a t1 t2 t1
T1
plus
plus
t2, right?
yeah,
These are things that we need to remember, like point of intersection of tangents or normals are standard things from any point. And now if it is a focal chord, what is t1 t2
-1.
for a focal chord? So put that here. So it is minus a t1 minus 1 by t1, let's say. This is your point of intersection of tangents, right?
Yeah,
Yeah,
right.
And here it becomes a t1 square plus 1 by t1 square minus 1 plus 2, so plus 1, right?
-1.
And here it becomes minus a into minus 1. So a into t1 minus 1 by t1, right? Correct.
Yeah.
Now these are point of intersection of tangents is x1, y1. This is x1, this is y1, and this is x2, and this is y2, right?
Hmm.
Yeah.
Now you can see easily that y1 is equal to y2 first of all.
Yeah.
And I think that's all for solving the question. The options will be there. Y1 is equal to y2, I think. Right?
Hmm. Options.
Correct.
Yeah. Yeah.
That is the option C.
Yeah.
So again, parametric form, like the reason you did not get this is just because you're not, you don't remember these things very well. That's why. Just have to revise a little bit. These are stuff that we have done earlier. Point of intersection of tangents, normals, parabola, ellipse, hyperbola. Just revise from SL only a little bit. Like these, this is all standard knowledge, right?
Yeah.
Yeah.
If you have any other doubts, send right now. Otherwise, I will discuss the questions. Do you have any other questions?
Could we revise ellipse and hyperbola?
Okay, we can revise it. Parabola is fine.
Yeah, parabola is fine.
So what is an ellipse? What do you mean by ellipse?
Ellipse is-
Like the distance from a fixed point is a ratio.
Correct. Locus of P such that distance of P from a fixed point SP is equal to E times distance of P from a fixed line PM, right?
Yeah.
PM is distance of P from fixed line. A line is directrix, right?
Yeah.
The
Right.
line is directrix. SP is distance of P from focus. Focus is S. And E ratio is less than 1 for an ellipse. Correct? Now, if you choose your point and the line in such a way that focus is say minus AE comma 0 and stuff, correct?
Yeah.
In general, this equation will become a 2-degree equation like this, right?
Yeah.
Because the line will be arbitrary and the point will be arbitrary. So in general, you'll get like this. But if you take a special case, you might get a situation like this where these are your points. The lines are here. Lines are x is equal to a by e and x is equal to minus a by e. These are the two directrices and the points are here. This is ae comma 0 and minus ae comma 0. This is s1, this is s2, and this is m1, let's say, and this is m2. So your locus is such that point is equidistant. PS1 is equal to E times PM1, right?
Right. Yeah.
PM1 is this distance and PS1 is this distance. It is always satisfying PS1 is E times PM1.
Yeah.
And it is also satisfying PS2 is E times PM2.
Okay. Yeah.
right?
Yeah.
In this case, the equation of the ellipse becomes x square by a square plus y square by b square is equal to 1. In this case, here this point is minus a comma 0 and a comma 0. That becomes your major axis. That is length, total length is 2b, and this point is 0 comma b and 0 comma minus b. That is your minor axis. Total length is 2b here, right? Correct.
Yeah.
Yeah.
And you can also draw a lattice rectum from here. Those will meet at ae comma b square by a and ae comma minus b square by a and all. And you will get length of the lattice rectum will be 2b square by a.
Mhm.
Correct?
Yeah.
Are you understanding this, all of this stuff?
Yeah. Yeah.
Yeah.
How did we get this equation? We just took distance here. So if you think about it, uh, PS1 would have been what? X plus AE whole square plus Y square, right?
Vice. Yeah.
And that is uh, E times E square times whatever is the distance here, right? This would be X plus A by E.
A by E. Mhm.
X plus A by E whole square.
Yeah.
You'll simplify it, you will get the equation.
Mhm. Yeah.
Right?
Yeah.
Yeah.
Now, the next thing is to understand basic stuff like a point is inside, outside, an ellipse depending on the sign of x square by a square plus y square by b square minus 1.
Hmm.
If the sign is negative, then it is inside. If it
Right.
is positive, it is outside,
Hmm.
right?
Yeah.
Yeah.
In an ellipse, if you have drawn an ellipse like this, you can also define something called an auxiliary circle. So if you have x square by a square plus y square by b square is equal to 1, the equation of the auxiliary circle becomes x square by a square plus y square by a square is equal to 1.
Mhm.
Basically, the circle on the major axis has the diameter.
Yeah.
Yeah. Right.
X square plus y square is equal to a square is my auxiliary circle. Why is this auxiliary circle important? Because we will say that any point P on the auxiliary circle, right?
Right.
You can join it to the origin and you can say that this point would be a cos theta, a sin theta, right?
Yeah.
Yeah. Right.
A cos theta, a sin theta, it would be, right? And that would mean that this distance is a and this angle is theta, right?
Theta. Yeah.
If you
Hmm.
drop a perpendicular from there like this, correct, then to this point, then you would have gotten this point here, which is a cos theta
A cos
comma 0,
theta. Yeah.
right?
Hmm.
And this point here would have been a cos theta comma b sin theta, right?
B sin theta.
Because this point lies on the ellipse, no?
Yeah.
So basically what I'm saying is if you put a cos theta for x here, y has to be b sin theta in the ellipse, right?
Correct.
Correct. Yeah.
So any point on the ellipse, any point on the ellipse can be represented in a parametric fashion, can be represented as a cos theta b sin theta. But what you need to keep in mind here that this theta is not this theta, right?
Yeah, it's not the same.
It is not joining the origin to the point on the ellipse. It's joining the origin to the point on the auxiliary circle,
Yeah,
right?
right.
Because from the circle you drew a perpendicular down, and that met the ellipse somewhere, right?
Yeah. Yeah.
Don't make the mistake of thinking this angle is theta. That is not true. Once you know your auxiliary circle on a parametric point, we will be using this parametric point in doing many things, because obviously like it has only one variable theta.
Mm.
So you can find equation of chord between any 2 points on the ellipse by saying just join by straight line a cos theta 1 b sin theta 1 and a cos theta 2 b sin theta 2, right?
Mm.
If you connect a straight line between them, that is equation of the chord on an ellipse joining 2 points.
Right. Yeah.
That equation comes out to be something like this: x by a cos theta 1 plus theta 2 by 2 plus y by b sine theta 1 plus theta 2 by 2 is equal to cos theta 1 minus theta 2 by 2,
Mm.
right?
Yeah,
Then obviously equation of tangents and all is easy. Like there are two ways in which you do equation of tangents and stuff. One way is tangent at a point. Tangent at a point, you will do the same thing that we do in all curves. We just replace x square with xx1.
And y square with y.
All 2-degree curves, you can do this. This becomes tangent at x1, y1. And if
yeah, right.
x1, y1 can be written as a cos theta, b sin theta, you'll get the other equation, which is x cos theta by a plus b y sin theta by b is equal to 1, right?
Yeah.
That is one way to write a tangent. The other way to write a tangent is by saying that, okay, a line y is equal to mx plus c can cut the ellipse or touch the ellipse or not intersect, right?
Mm.
So if you solve y is equal to mx plus c with this curve, then you will get the condition on discriminant 0, not 0, greater than 0, right?
Correct.
Discriminant is 0, it is a tangent condition because it is
Tangent.
touching. That will be c square is equal to a square m square minus b square, right?
Right.
If
Yeah,
discriminant is less than 0, there is no intersection.
No intersection.
And if discriminant is greater than 0, it is a chord or it's a secant line,
Yeah.
two intersections, right? So all of this is straightforward stuff. You will get the tangent equation from here as y is equal to mx plus root over a square m square plus b square. C square was a square m square plus b square, right?
Yeah.
yeah, right.
So that is one type of a tangent equation where slope of the tangent was given to you. If slope was given, you would use this. If point was given, you would use this, right?
Hmm.
Now, again, things like point of intersection of tangents, point of intersection of tangents at, let's say, theta 1 and theta 2. It's just about writing two equations and solving them, right?
Mm-hmm.
One tangent equation would be x by a cos theta 1 plus y by b sin theta 2 is equal to 1. The other equation would be x by a cos theta 2 plus y by,
Because
this is
theta.
theta 1, plus y by b sin theta 2 is equal to 1. And if you solve for x and y, you should get the point of intersection. You should remember this: x is equal to a cos theta 1 plus theta 2 by 2 by cos theta 1 minus theta 2 by 2, and
Mhm.
y is equal to a b sin theta 1 plus theta 2 by 2 by sin theta 1 minus theta by cos b sin theta 1 plus theta 2 by 2 by cos theta 1 minus theta 2 by 2.
Mhm.
Basically, this is your point of intersection. of the two tangents at points theta1 and theta2.
Right.
It will come by just solving. Like if you are given some values and all, it will be easier to solve. You can check it out. But in general, like in before the exam, you need to remember results like this, like point of intersection of tangents and stuff,
Yeah,
right?
right.
Then equation of normal is obvious. You just write the equation of straight line passing through x dash y dash, but perpendicular to the tangent slope, right?
Yeah.
So don't try to memorize the equation of normal. You can just derive it,
Mm-hmm.
correct?
Correct.
And that can be written either in terms of the x dash y dash or in terms of theta point.
Theta.
There will be two forms. Both forms are equally valid. Then what else is there? Then uh, there are some geometrical properties that are there. One second. Uh, you need to know your focal distances of a point on the ellipse and all, right? Like focal distances is a plus ex, right?
Mm-hmm.
One second. Okay, one second. If I draw an ellipse like this, uh, let's say P is a random point here, P.
Mm-hmm.
Tangent and normal at P. Tangent at P would be like this, and normal at P would be like this. The tangent and normal at P meet the axis, x-axis, at least tangent meets it at T and normal meets it at G, right?
Right.
So by the way, this is your subtangent and subnormal stuff, right?
Mm.
In calculus, we have seen anytime tangent to a curve meets the x-axis and normal to the curve meets the x-axis, we can write your subtangent subnormal, right? This is one length. This can be marked as a point here. You can label it as n. This is your subnormal and this is your subtangent, the length.
Right.
We can show here that this center is C. You will be able to prove here that Ct into Cn will be equal to a square. So Ct multiplied by Cn will be equal to a square. You can also show here that Ng is to Nc would be equal to b square is to a square. How? So let's say our ellipse was the standard ellipse, x square by a square plus y square by b square is equal to 1. Let's say P is a random point x1 comma y1, right?
Right.
Then PT is a tangent, so equation of tangent is x1 by a square plus y1 by b square is equal to 1, right? So tangent intersects the x-axis, so y should be 0. So this point T should be when y is 0, x will be a square by x1, right?
Right, yeah.
A square by x1 comma 0, right?
Yeah.
And point N is obviously x1 comma 0, right? Correct.
X1. Yeah, right.
Equation of normal PG is basically x minus x dash by x1 by a square is equal to y minus y dash by y1 y dash by b square. This is standard equation of normal. You know how to write get that, right?
Hmm.
In this you put y is equal to 0, you will get x minus x dash by x dash by a square is equal to minus y dash by y dash by b square. So minus b square, you'll get minus x dash b square by a square plus x dash. So x is equal to x dash 1 minus b square by a square, right?
Yeah.
Correct.
Correct.
So this becomes 1 minus b square by a square is e square, right?
Correct.
X dash e square.
Yeah.
So G point is basically G point is e square x dash comma 0, right? And C point is 0 0.
0
Okay.
0.
So CT is a square by x1, Cn is i- just x1, right?
Hmm.
So CT into Cn is what? A square, right?
Yeah.
And Gn is how much? Gn would be Cn minus Cg is equal to Gn, right?
Yeah. Yeah.
And Cn is x1 minus Cg is e square x1, right? That is your Gn. And Nc is how much? Nc is similarly x1, right?
Right.
So basically Gn by Nc is equal to x1 1 minus e square by x1. So this is 1 minus e square. 1 minus e square is 1 minus 1 minus b square by a square.
Good, nice. Hmm.
So that is equal to b square by a square, right?
Yeah.
So Gn by Nc is this, correct?
Correct.
This Gn is called subnormal because it is the distance between this perpendicular point and the point where the normal cuts the axis. Nt is the
Mhm.
subtangent, and subtangent distance is coming out to be what? Nt is basically Ct minus Cn. So Ct was what? Ct was a square by x1 minus Cn. Cn was x1, right?
Yeah.
This is your subtangent. Fine. And subnormal Gn is coming out to be just we wrote here x1 into 1 minus e square, right?
Correct.
Okay. Now let's in the same figure let's put focus also somewhere, right? Let's say focus is S is somewhere
Okay.
S, right?
Yeah.
So uh, one second. One focus is let's say here S dash and one focus is here S, right?
Hmm.
This G point was e square x dash. Okay, it depends on where x dash y dash was. So G could be this side or G could be this side. I don't know. I am assuming one focus S dash is here and one focus is here, right?
Yeah.
Okay. Now, what is S to G? S to G distance here right now, this focus to this, right?
Right.
That distance is SC plus CG, right?
SC plus CG. Yeah.
SC plus CG. And SC is AE, this much is AE, and CG is how much? E square X dash, right?
Correct.
Correct.
Yeah.
So now S to G is coming as this. Uh, Here you can take E common and it is becoming what? A plus E X dash, right?
Yeah. Yeah.
A plus E X dash. Now A plus E X dash uh, is a focal distance as far as I remember. 1 second. Is equal to focal distance of SP
Mhm.
because P was X dash Y dash. Focal distance is A plus E X dash.
Right.
I mean, think about it. There are two foci, right?
Yeah.
Any point's focal distance will be A plus Ex dash and A minus Ex dash. And therefore, sum of the focal distances becomes 2A, right? PS1 plus PS2 is equal to 2A. This you remember. Sum of the two focal distances should add up to hello.
Yeah. Hello, sir.
Yeah. There was some internet connectivity issue. So what I was saying was you need to know that any point on an ellipse, any point P on an ellipse obviously satisfies PS1 plus PS2 would be equal to 2A, right?
Yeah.
That is one of the definitions of an ellipse. The sum of its distances from the two locus of a point that moves in such a way is equal to 2A, right?
Correct.
So how does that happen? That happens because this is point x1 y1, then the focal distance, this is A plus ex1 and this is A minus ex1, right?
Yeah.
So earlier when I was saying SG was equal to SC plus CG and we had gotten it as AE plus E square x1, right? And
Mhm.
that E common, it became A plus EX dash, and A plus EX dash is distance of X dash from that focus, right?
Yeah.
Focal distance of that X dash Y dash from the focus. So E times SP, right?
Mhm.
In the previous
Yeah.
figure that I had drawn, right? Correct. And similarly,
Correct.
S dash G, if you say S dash was this focus, S dash to that G would be basically CS dash minus CG. G was the point where the normal intersected the axis, right?
Mhm.
So like normal, let's say intersect with the axis here. This is G, this is center. So you're saying CS dash minus CG is equal to S dash G, right?
Yeah.
Yeah.
And that became CS dash became uh CS dash became AE and minus this was E square x1, this point G point, so minus E square x dash, right? So this became E times A minus EX dash, which is S dash P, right?
Correct.
now you're getting SG by S dash G is equal to SP by S dash P, right?
Yeah.
Correct.
Correct.
So the normal, so this is S, this is S dash. You're getting SG by S dash G is equal to SP by S dash P, right?
Yeah.
That is a very important geometrical thing. Now think about it. Look at a triangle. This triangle, right?
Yeah.
PSS dash. If you have this by this is equal to this by this, that means this is angle bisector, no?
Correct.
Angle bisector divides the base into the ratio of the sides containing them, right?
Yeah.
So what is happening here? What we are getting here is that the normal, the normal at any point of an ellipse
Mm.
bisects the angle SPS dash, right? Where
Yeah.
SPS dash is like join it to the focus, both the focus.
Right. Right.
So normal will always bisect that angle. In a similar way, you can also show that the tangent will bisect the exterior angle.
Yeah.
This SPS dash is this angle. There will be an exterior angle also, right?
Yeah.
Yeah.
Tangent will bisect the exterior angle. Normal will bisect the interior angle.
Right.
This is an important property which might come in handy at some stage. Like this will be true for all ellipses. So it doesn't matter how what kind of an equation it is and stuff. It will always be true, right?
Right. Yeah.
Then there is also stuff like locus of point of intersection of tangents which meet at right angles. Basically, director circle, right? The way you
Mm-hmm.
derive those, you should know first of all the equation of director circle is this for an ellipse. How do you derive this? Basically, it should be the locus of point of intersection of perpendicular tangents to an ellipse, right?
Yeah.
The way you derive it is say that any tangent of the ellipse can be written like this, right?
Yeah.
And therefore, a perpendicular tangent to it would be like this,
-1.
right?
Correct.
Now, you have to say that their point of intersection is h comma k, right? And you have to find locus of this, right?
Correct.
So you have to solve for h comma k. You have to solve by eliminate like h comma k lies on both of them. So put hk here and eliminate m,
M.
correct? You will get something like k minus mh is equal to root over a square m square plus b square from the first equation, and you will get here again k mk plus h is equal to a square plus b square m square from the second equation.
Right.
And now how do we eliminate m here? What you should do is you can square and add both sides, right? You will
Uh-huh.
get k minus mh whole square plus mk plus h whole square, k minus mh whole square plus mk plus h whole square should be equal to a square m square plus b square plus a square plus b square m square. So that is a square plus b square common m square plus 1, right?
Right.
Correct. And this side also, if you do, you will get m square k square plus k square, m square h square plus h square, right? and the other terms
Yeah.
cancel. You'll get h square plus k square into 1 plus n square. This cancels and you get the locus.
Mm-hmm.
This is how you get director circle to an ellipse. Then pair of tangents from a point would be ss1 is equal to t square. Those things we already know. The same rules apply, whatever you have learned in earlier chapters, right?
Yeah.
But those are not going to be super important. You will have one more point that is crucial is this. Uh, in general, in general, how many normals can be drawn from any point to an ellipse? How many normals? How many normals can be drawn from a point, drawn from an arbitrary point to an ellipse? So we'll show that it is possible from a point to draw 4 normals to an ellipse. Okay.
Okay.
So equation, say, let's say we have an ellipse x square by a square plus y square by b square is equal to 1. And at the point theta, the equation of the normal by in the parametric form, you can derive it. It will come out to be this ax by cos theta minus by sine theta is equal to a square minus b square,
Mm.
right? This can be
Yeah.
derived
Yeah.
easily. Like you will just do the find the equation of tangent, slope of tangent, and then do y minus y1 is equal to minus 1 by slope of tangent to x minus x1, right? x1 and y1 are a cos theta b sin theta, correct?
Yeah.
Everyone understands, no, that this can be gotten. It's not a big
Yeah.
deal.
Yeah.
Then what I want to say is you have drawn this normal from some arbitrary point h comma k. So from h comma k you have drawn a line and this line has cut the ellipse at this point as a normal, right?
Yeah.
Basically what we are trying to say is from some random point I have drawn one normal, one more normal, one more normal, something like that, right? This
Mm.
point is h comma k. I say this point was theta where this is the normal. So h comma k lies on it, right?
Yeah.
Yeah.
So h comma k lies on the normal. Therefore, you have ah by cos theta minus bk by sine theta. And this a square minus b square can be written as a square e square, right?
Correct. Yeah.
Now, uh, this equation, this equation, we can convert into an equation like we want something in terms of theta here. So what we can say, because we want to say how many such points are possible, theta 1, theta 2, theta 3, how many such points are possible, right? From
Right.
a given point, how many normals can we draw? That is what we want to say, right?
Yeah.
Yeah.
Right.
So we want to make it an equation in theta. Like we don't want, we know hk already, right? The
Correct.
unknown here is theta, right?
Yeah. Yeah.
If you can say that it's a quadratic in theta, then you'll have two roots for theta, no? Correct.
Yeah.
If it
Yeah.
is a cubic in theta, we'll have three roots for theta. So I want to make it a quadratic or a cubic or a polynomial equation in theta,
Yeah.
right?
Mm.
So how do I do that? We will use the transformation of cos theta in terms of tan square theta by 2, right?
Right.
And sin theta as 2 tan theta by 2 by 1 plus tan square theta by 2. Correct? If you
Hmm.
use this and then take tan theta by 2 as t, so you'll have cos theta as 1 minus t square by 1 plus t square, and sin theta as 2t by 1 plus t square, right?
Correct.
And then you will simplify it. You'll simplify it like this: ah 1 plus t square by 1 minus t square minus bk 1 plus t square by 2t is equal to a square e square, right? And
Hmm.
after a little bit of simplification, you will get a fourth degree equation in t: bk t power 4 plus 2t cube ah plus a square e square plus 2t ah minus a square e square and minus bk,
BK. Okay.
right? This fourth degree equation will have four roots where you will get t1 plus t2 plus t3 plus t4 and stuff, right? Sum of the roots,
Right.
product of the roots, you can write from here now. None of them is so important, only the last one is important. T1, T2, T3, T4. Product of all the roots is coming out to be -1, right?
Yeah.
See here, correct. So what you're getting is tan is product of the tans is coming out to be -1, correct?
Yeah.
Tan theta 1 by 2, tan theta 2 by 2 and stuff, right? Tan theta 3 by 2. Because T1, T2 and all was tans, right? Tan theta 1.
Yeah.
Correct. Now, we know in trigonometry we had seen tan of multiple angles. Tan of multiple angles, if you do sum, that was S1 minus S3 by 1 minus S2 plus S4, something like this. If I have to do tan A plus B plus C plus D, I would do S1 minus S3 by 1 minus S2 plus S4. What is S1? S1 is sum of all the angles tans. S3 is sum of all the angles taken 3 at a time.
Get it.
S2 is taken 2 at a time and stuff like that, right?
Yeah.
Now here what happens is, if you see here, there is no S2 term, right? Square term is disappearing, right?
Hmm.
Sum of
Yeah.
T1, T2 would be 0, right? Here.
Yeah.
So S2 is anyway 0, right?
Correct. S2 is 0.
And S4 is -1. So S4 plus 1 is 0, right?
Yeah.
So this whole
Get it.
denominator is 0, so it is infinite. So this sum of all these tan angles must be pi by 2, right? So you should have
Correct.
theta 1 by 2 plus theta 2 by 2 plus theta 3 by 2 plus theta 4 by 2 is n pi plus pi by 2 in general, right?
Yeah.
Correct. So if you remove the 2, you will get, this is adding up to be 2n plus 1 into pi, the sum of all the eccentric angles, right?
Hmm.
Basically
Yeah.
what we get here is that, first of all, there are four normals possible from any point. Four normals are possible because there are four roots to this quartic equation, right?
Right.
And four normals are not random. They are such that wherever they meet the ellipse or wherever they are normal to the ellipse, the eccentric angles will be such for those 4 points that it will add up to 2n plus 1 into pi, odd
Hmm.
multiple of pi.
Right.
Those four
Right.
eccentric angles. This is something that you need to remember. Like, they might This will not come in mains, but they might come in similar questions, could come in advanced. There is
Okay.
nothing much else in Ellipse. You should practice some objectives and all for this, and just revise hyperbola a little bit. We can discuss hyperbola in the next class. We'll do class tomorrow. I want to finish the maths revision at least from a mains perspective quickly. Like whatever is needed, we'll revise. We'll do classes every day. Okay. Uh,
Yeah.
have you guys written tests in the last month or so? Mains tests?
Yeah,
How are your mains marks coming these days? What is happening?
like now there are revision tests going on.
Roughly, what is the average marks both for both of you? What are you getting these days?
1 second. Like last test, I got like 203, I think.
And in general, like last 4-5 tests, they would be part by part syllabus tests, right?
Yeah.
So far, full tests have not yet started.
No,
No.
not yet.
Are you getting 200 or thereabouts every test?
Yeah, I'm getting like around 190, 180.
Okay. So ultimately, like 190, 200 is what you need to get. That is going to give you a good percentile. So that is what you have to target, 190, 200 plus every test.
Okay.
If you are getting that, then it's fine. If you are getting lower than that, then you have to work on the revision part a little more. Right?
Right.
Yes, sir. Yeah.
So what we will do is we'll do a mains focused maths revision first, and then we'll move on to physics. So for the next few days, we'll have continuous classes. We'll have classes every day, and I will be doing maths for mains. So let's just work on that till we finish the entire syllabus. So if you want, tomorrow we can do hyperbola, or we'll do practice questions from mains from any portion of the syllabus. So, or you have any doubts, then bring them tomorrow. Whatever. Okay.
Okay, sir.
When is your full test starting? Full syllabus test?
Test is on.
I think February.
And JEE mains and all, they have not announced dates, right? So far. Anyway, then
9th.
what?
9th Feb is the first full syllabus.
Okay. Anyway, there is a new corona wave, so I don't think it will be in mains will be in Jan anytime possible. It's not possible. So
Not.
I think mains will be in April and all again.
Yeah,
I don't
mostly
know.
March.
Yeah.
Yeah.
Your CBSE part 2 is in March, right?
Yeah, that's also there in March. So
Okay. So this month we'll focus on mains only mostly, and make sure that you need to consistently get above 200. If you're getting above 200 consistently, then you don't need to worry about it. Then you just need to do it well on the day of the exam. You will get a very good percentile, 99 plus.
right.
Okay.
So above 200 is the target. Work on that. We will be focusing on that for this month.
Yeah.
Okay. Tomorrow I'll see you guys again, same time, and we'll do maths. Bring your doubts. Otherwise, we'll do some questions, and from hyperbola also we might do something. Okay.
Okay.
Okay, sir.
Okay. I'll see you tomorrow.
Yes.
Bye.
Bye.